Assalamu alaikum. In example 3 of module 10, we are speaking about timers. This example is interesting. It will combine the interrupt with the timer checking. So let's see the question. So write a C program using timer 2. So it asked me to use timer 2 to flash an LED every 50 milliseconds. So now the blinking time is longer. Suppose we have an external clock 16 megahertz. So as we did before, we calculate the T. So it's 62.5 nanoseconds. We calculate the timer count. We need 50 milliseconds this time. Last time it was 8, so now it's much more bigger. It's 50 milliseconds. We divide -1, so we get 799,999. Of course, it's out of the range of timer 2, which is 8-bit timer, so it is 255. Its maximum is 255. If we use the prescaler, the biggest prescaler that we can use is 1024. So if we apply the 1024, we calculate the new frequency, then the new period, we calculate the new timer count. We get, by dividing 50 milliseconds by the new T -1, we get 780. So again, it's bigger than 255. So the maximum prescaler is still not enough to solve this problem. So what we should do, we are going to use the interrupt. Let me explain to you how. So the idea is that the timer will generate an overflow interrupt every 256 counts. So when it counts from 0 to 255, when it reaches the maximum, it will generate one interrupt and start again to 0. So we need to know how many times we need the timers to repeat the complete count before it reaches 780. So the required delay is greater than the maximum possible delay, which is 256 multiplied by 64 microseconds, the new frequency that we calculated. So the maximum is 16.384 milliseconds. So 16 milliseconds, but we need 50 milliseconds. So we need to write a program to trace the timer overflow. So we need to count the overflows, and whenever the timer overflow, an interrupt is fired, of course, and this fire will call an ISR function, which we will use to keep tracking of the overflow. So how many times should the interrupt fired? Let's calculate. So we divide the 50 milliseconds by the 16 milliseconds. So we have 50 milliseconds. The overflow happens every 16.3 milliseconds. We divide them, we get 3.05. So we need 3 overflows plus small time. Or we can divide 780 by 255 and we will get the same value. Now, by the time the timer has overflown 3 times, we will get 49.152 milliseconds. Just multiply 3 by 16.384. So after 3 iterations of overflow, we need to calculate a small time now to complete the delay to 50 milliseconds. So it's 50 milliseconds minus this value, we will get 0.848 milliseconds. So we need to calculate this small interval that complete the 3 iteration plus this interval will give us 50 milliseconds. So the interval is 0.848 milliseconds. We divide it by the new frequency -1 and we get 13. So we need 1 overflow, 2 overflow, 3 overflows plus counting from 0 to 13. So 256 plus 256 plus 256 plus 13. So in the 4th iteration, we need the timer to count up to 13 and then reset. All this can be achieved in the ISR. Let's see the program after include. So we will make this global variable to count the number of overflows. Okay, so we need to calculate 3 overflows. We set the timer prescaler to 1024 using the TCCR2. We initialize it to 0 and we enable the overflow interrupt in TIMSK. And don't forget to enable the global interrupts. And the total overflow, we initialize it to 0. Now, in the ISR, every time the overflow is fired, we will increase total overflow by 1. So it's initialized by 0. First overflow, it will be 1. Second overflow, it will be 2. And third overflow, it will be 3. This variable. Now, in our program, make DDRC the bit 0 as output. We call the initialization function. And this is our main program. So, if total overflow is greater than or equal to 3, that means we count 3 overflows. Now, second condition, we wait until TCNT2 reach 13. When it reaches 13, we toggle reset TCNT2 and reset the total overflow. So now we have two conditions. Condition 1 is counting to 13, but counting to 13 is after counting 3 overflows. So this program will solve the problem. Let's see how we apply it on the same circuit of example 1 and 2. Again, the same circuit is used, but this time with the new program in AVR Studio. So we upload the new program, we build it, and we go to the circuit and upload the hex file to our simulator. We run the simulation and you see it's taking now much more long time to do the blinking. Okay, so it's just simple examples to show you how to deal with the timers for doing some actions. Of course, these actions can be more complicated things like running some devices or so on, but here we just want to see the signals. That's why we are using the LED. Thank you for listening and see you in next video.